Hello and welcome to this session of K-means clustering. I am Dr. Fakat Kazmi from Core Hub. Today we will explore what K-means clustering is and how it works. K-mean clustering is an unsupervised learning algorithm used to group a set of data into clusters based on their similarities. Unlike supervised learning, you don't have labeled data. Instead, you want to identify inherent grouping in your data. For example, if k is equal to 2, the data will be grouped into 2 clusters. If k is equal to 3 clusters, and so on. Determining the optimal number of clusters is part of the process we will explore. Example: cricket players. Let's take a practical example using cricket. Suppose we have data on cricket players that includes the number of runs scored by the number of wickets taken by each player. We want to cluster these players into 2 groups, batsmen and bowlers. Batsmen generally score more runs while bowlers take more wickets. There will be some overlap, such as bowlers who score runs and batsmen who take wickets. But our goal is to cluster them based on their primary roles. How K-mean clustering works? Number 1. Initialization. The first step is to allocate k centroids randomly. For k is equal to 2 points are assigned as initial centroids. Number 2. Assigning data points. Each data point is then assigned to the nearest centroid. The distance between each data point and centroids is calculated and the point is assigned to the closest one. Recomputing centroids. Once all points are assigned, the centroids are recalculated as the mean of the points in each cluster. Number 4. Iterating the process. Steps 2 and 3 are repeated until the centroids no longer change significantly. This indicates the clusters are stable and the algorithm has converged. Types of clustering. Clustering techniques can be broadly categorized into: Number 1. Hierarchical clustering. Agglomerative. A bottom-up approach where each data point starts as individual cluster and merges into large clusters. Divisive. A top-down approach that starts with one cluster and divides it into smaller clusters. Number 2. Partitional clustering. K-mean clustering divides data into k clusters based on similarity. Fuzzy C-mean clustering, similar to K-means but allow data points to belong to multiple clusters. Applications of K-mean clustering. K-means clustering is widely used in various fields such as academic performance, categorizing students based on their scores, search engines, grouping search results for better relevance, wireless sensor networks, identifying cluster heads to collect data. Distance measures. Distance measures are crucial in K-mean clustering to determine the similarity between data points. Common distance measures include Euclidean distance, Manhattan distance, squared Euclidean distance. Thank you so much.